Hi, my topic is GSPS DACS Enable Ultra-Wide Bandwidth Application. Presented by analog devices and IVNet to meet increasing capacity demand of all customers. The emerging E-band market requires wider bandwidth capabilities compared to traditional microwave backhaul wireless architectures. Due to increased capacity, 2 GHz E-band system will be needed in the near future. Here's a video explaining. Okay, this webcast covered the demands of current E-band point-to-point systems and how ADI high-speed DAC provides the necessary bandwidth and sampling frequencies to support them. Overview of microwave point-to-point PTP system requirements and architecture, specifically E-band under some areas of increased difficulty for system design specs, bandwidth, channel separation, sampling frequency.
Bandwidth of signal. In a communication system, the message signal can be voice, music, picture, or computer data. Each of these signals has different ranges of frequencies. The type of communication system needed for a given signal depends on the band of frequencies which is considered essential for the communication process. For speech signals, frequency range 300 Hz to 3100 Hz is considered adequate. Therefore, speech signal requires a bandwidth of 2800 Hz, 3100 Hz to 300 Hz for commercial telephonic communication. To transmit music, an approximate bandwidth of 20 kHz is required because of the high frequencies produced by the musical instruments. The audible range of frequencies extends from 20 Hz to 20 kHz. Video signals for transmission of pictures require about 4.2 MHz of bandwidth. A TV signal contains both voice and picture and is usually allocated 6 MHz of bandwidth for transmission. In the preceding paragraph, we have considered only analog signals. Digital signals are in the form of rectangular waves as shown in figure. One can show that this rectangular wave can be decomposed into a superposition of sinusoidal waves of frequencies V0, 2V0, 3V0, 4V0.
Review AAD high-speed DAC products, specifically AAD number and the codes that are specific there that support the new system requirements. Learn about the product features of the new PTP system design, evaluation guide, kit options for DAC products.
So 5G is a big buzzword in this industry right now. So key players talking about moving up in frequency to millimeter waves like 20 gigahertz, 30 gigahertz, 40 gigahertz, 60 gigahertz, even 80 or 70 gigahertz. And why we do that is we're finding more bandwidth, so to realize higher data rates. So the bandwidths that we're talking about are in the 2 gigahertz realm. And then, of course, as a test equipment vendor, we have to provide solutions to analyze such ultra wideband signals and to generate them. So this is basically the setup that we have here to do that. So we're utilizing a wideband ARP, arbitrary waveform generator, that we connect over analog IQ to our vector signal generator, the SMW200A. Right now I'm using here a 2-channel model where both channels go up to 20 gigahertz. The demonstration that we do here is right now at 18 gigahertz. So we're getting that waveform from the arbitrary waveform generator, analog IQ in, we're utilizing the 2 gigahertz IQ modulator of the SMW, we up-converted to 18 gigahertz, and then we're taking out that signal here and it's feeding it into our spectrum analyzer, the FSW. The FSW is a unique product. It offers 2 gigahertz analysis bandwidth in conjunction with our RTO oscilloscope, and it goes all the way up to 67 gigahertz by itself. So what we basically do here is we're feeding that 18 gigahertz signal in here, down converted to the first IF stage, taking that signal out, feed it into the scope acting as an external digitizer basically, has a 4 gigahertz bandwidth at this point, so we're utilizing that here, and then we're feeding the IQ samples, the digitized IQ samples back into the analyzer and doing a modulation quality measurement. As you can see here, we have an EVM of about 3%. We're using a 16 QAM signal, and if you're looking at the power spectrum or at this rate here, it's a 1.6 gigahertz wide signal that we analyze. So basically this is utilized today by researchers in order to start developing transceivers for 5G at the millimeter wave frequency ranges with that wide bandwidth, and that's what Rosensport supports with the test equipment.
And that concludes the presentation.